So then if you wanted to find out what the inverse would be, you would minus it from 1, so it would be 100%. And it gives you, I mean, you disregard the negative, but
yeah.
Sleep if you want to.
Like, that's how I do it.
Well, the number you get here, I'm not sure why you put that there. What is Q? 24.8, so why did you put 1.2?
Alright. So I was pushing back and forth.
So let me catch up to you guys, because I kind of forgot to put that on there, so I want to explain those a little bit. So up here, I am going to use 44 people. And P, of course, was the 0.152, because I'm talking about smokers here, right? So that's 0.152. This is going to be the rest, 0.848. Just 1 minus this, right? So Q is always 1 minus P. So that it's the rest, what is left over for the failures. I give you a little bit in the middle about how to plug it in the calculator. So probably exactly 7 smoke. So then I'd have 44 people. I want to choose 7 of them. So I'd have 7 successes, and the rest, how many is that? 37 would be failures. So if you plug this in the calculator, yeah. So what's that mean? About 16% chance that if I pick 44 San Diegans, that exactly 7 of them will. So that knowing that exactly, the probability exactly 7, that's kind of stupid. That's kind of like, why would I know exactly 7? So very often what we actually want to know is the probability of at least 1. Right? So if the probability of at least 1 smoker is high, then I want to make sure that there's an ashtray somewhere. You guys kind of understand the usefulness of this? The probability to have at least 1 person that's very tall, then I want to make sure that there's nothing that's going to hit him in the head. You see what I'm saying? If it's a very low probability, maybe I'm not going to be very concerned about it. Alright, maybe. So here, I'm kind of building up to that. The probability that none of them smoke, so I'd have 44 people, I want to choose nobody. So I want no successes, and I want nothing but failures. Which in this case, the failures are actually better off. So what is all that mess? To be honest, what's this? What's 44 choose 0? 1. What's anything to the 0 power? 1. So really, you just put that in the calculator. So what do you get? 0.848?
7.0699.
Oh yeah, cool. Times 10 to the... So what you actually get is this, 7.0, yeah, exactly. 699, blah, blah, blah. E negative 4. So what that means is 7.0, let me just say 7, times 10 to the negative 4th.
Like 0.007.
Yeah, so the nifty thing is, if it's negative, that means you have 1 less 0 in front, because you got to move the decimal once, and then 3 more places to move it to 4 times. So it's 0.0007. And since I said 4 places, you could actually stop there, right? Man, that was like Plinko. Sorry. Let me stop there for a second. So I like the fact that somebody said, did I do something wrong? Because I got 7, and that's bigger than 1. That's beautiful. Never write 7 down for a probability. What the hell? 700% chance. Yes?
So, what if it said the probability that, like,
At least
30
2.
of them didn't smoke or something?
Oh, then my P and my Q would switch. And then I would do, just like I did here for 7, but then I put a 3, but my P and Q would switch.
Yeah, because I thought B would switch at first because we're not talking about people that smoke. That's why.
There are 2 kind of ways to look at part B, but if you want to keep everything the way it is, not just none of them smoke means 0 smokers, so 0 successes. Because they've got success defined to be a smoker.
It would be the same thing, actually.
It'd be the same thing. Mathematically, if you move that over and you move that over, it's the same thing.
Okay.
Maybe. Alright. So we know this. Some other building.
I didn't know college had biodrills.
Science building.
Oh yeah, especially chemistry building. This is where my office is, so sometimes it's a drill and sometimes it's somebody spilled a chemical or something. It's exciting.
Didn't it go off for burnt popcorn once before. I'm
Maybe.
sure it last semester. Or something
Really?
Like that. They had to evacuate the whole building because of burnt popcorn.
That's
That's crazy. Burnt popcorn, it'll get you. It'll kill you.
You can smell it, it lingers.
Alright, so watch this. I'll often do this. Guys, so the probability at least one, in fact, in general, any probability is 1 minus the opposite probability. Right? So anytime that the opposite probability has less work, I'm going to do this. So how much work would it be if I wanted to do this directly? Well, it could be 1. So I'd have to do a formula for 1. Or it could be 2. So I have to do a formula for 2. Or it could be 3. So I have to do a formula for 3. Do a formula all the way up to 44. You want to do that? If you want to do that, sure, why not? But I'd much rather do 1 minus the opposite, because how many ways is there to do that? 1. In fact, I already freaking did it. So it'll be 1 minus 0.0007. Which is 0.9993. So if I randomly select 44 San Diegans, it's almost guaranteed that at least one of them will smoke. You guys follow? But what was the probability somebody smokes? 15%, right? So that's a very low probability. But the minute I get like 42, then the probability at least one smokes is high. So that's related to the birthday thing that we did. Remember the birthday thing we did? So the probability that anybody has the same birthday as somebody else is very low. But the minute I get like around 40 or something people, it gets stupid high. And that's why I was like, I'll put money down on this because I feel pretty good about my chances. And we ended up having 2 people or 3, 4 people. Again.
There's only 1.
Aw. Couldn't let me have that. But one is good. All right. So I want to explain why this makes sense. I always pick on Shaquille O'Neal. You guys remember Shaquille O'Neal? He's still doing stuff. I pick on him because he was on the worst team, the Lakers. Sorry if you're a Lakers fan. I'm a Celtics fan forever, right? Larry Bird was my hero when I was a little kid. I'm like, I'm white, and this guy can play basketball. And I was short, so I had a really good fadeaway shot, right, when I was playing basketball. So Larry Bird is my inspiration. But Magic Johnson, I'm like, oh God, you're so good, but you're on the wrong team. Damn. So Shaquille O'Neal, let's say he makes like 30% of his free throws, right, which is not too far off from what. Actually, Shaq was a Celtic for a little while, but he was mostly a Laker. And let's say he makes 30% of his free throws, right? And he takes 20 free throws. So 30% would be a probability of success. So this is a binomial situation. He's going to make it or not. So if he makes 30% of his free throws and he takes 20 of them, how many would you expect him to make? 6. 30% of 20. So that's what this says. The expected value, which is the average, is the probability of success times how many? 30% of 20. That's how you got 6. That's why that formula makes sense. This formula, I can't explain to you. It takes a little bit more math than we have at our disposal, right? I'll see if I can't, well, I don't know. It takes a little more than we got. But that's the formula for the standard deviation. That is the best freaking couple of formulas we've ever had. Look at that. That's too beautiful to believe. There's no tables to make. It's just if you know NP and Q, you know the mean, you know the standard deviation. So what's the mean here?
6.688.
Sorry, let me catch up to you. So it would be 44 times 0.152. You got what now? 6.688? Mm-hmm. And then the standard deviation would be this whole mess. What do you guys get, sir?
5.6714.
5 point?
I got
2.38. Oh, maybe you didn't square root or something? No.
I
Sounds like
was
you square
doing
root.
from the beginning and
I
then
got 0.8549.
I got 2.44.
You have dissension in the ranks. Let's see. 0.848. Please do something about that, Lauren.
2.38.
Yeah, 2.381. So try.
I did it, but I just did it from the beginning.
But do you get that number?
Yeah.
Okay. I'm sorry. Okay. And then finally, the idea of unusual, I don't think it's come up yet in the book, or I haven't said it either yet. But unusual things would be outside of 2 standard deviations away. Because 1 standard deviation away is, and remember, what's a standard deviation? What does standard deviation tell you? Yeah, on average, how far the data points are from the mean. So if I go 1 step out, that's the average distance. So if I go another freaking step out, we're going to find out that we caught like at least 89% of the data, no matter what your data is. Which means anything outside of 2 steps away would be unusual. Does that make sense? That's why we officially call that unusual. All right? So if I put the mean in the middle, this feels kind of familiar here, right? Put the mean in the middle, and I go 2 steps up. So add 2.381 twice to it. Where do you end up?
Add what?
11.3 or something? 11.4, blah, blah, blah. And if we go down twice, 1.92. So would it be unusual to find 17 if I picked 44 San Diegans? Would 17 be unusual?
Yeah.
Because it's way out here, right? This is my usual. I would expect between 2 roughly and 11. That's what I would expect to have happen if I picked 44 San Diegans. 17 would be very unusual. Because it's way outside of there. Alright, that's plenty. And right down to the wire today. So obviously we'll do more of that. But the first thing on Tuesday we're doing double quiz. Yay!
That is quick.
So,